How the following conversions can be carried out? Now, this is a long question with 20 subparts. Very interesting and very informative and very, very knowledge enhancing. So, pay attention and focus. Propene, you wish to convert to propane 1-all. If you just take care and look, what all do you have? Propene, fine. And the moment you want to convert this to propane 1-all, means you want to add H and OH. Hydration of alkene means addition of HOH or water. And this, my dears, is anti-Markovnikov addition. Anti-Markovnikov addition. What is the method for anti-Markovnikov hydration of alcohols? Hydroboration, oxidation. First, you add diborane B2H6 and THF solvent, and then you add H2O2 with OH minus. The moment you do this, you have HOH added in anti-Markovnikov fashion without any absolute rearrangement. This is the solution. Ethanol to but-1-ine. This is a repeated question. We have converted ethanol to but-1-ine as the very first part of the previous question 10.10. The 10th question first part is exactly the same. So since it is repeated question, there is no need for answering that. It's a good question, but we have already answered that. Look at the beauty of NCERT. They have repeated questions. And then we have 1 bromopropane to 2 bromopropane. Very interesting again. 1 bromopropane changes to 2 bromopropane. How do we do this? We could actually do this in 2 steps. If you have propene by any chance, and if you add HBr by Markovnikov rule, you will surely have 2 bromopropane. And how do I get alkene? Well, you take alcoholic KOH and you heat it. You get alkene. So 1 bromopropane, heat with alcoholic KOH, you get propene, add HBr. As per Markovnikov's rule, you get 2 bromopropane. This is the method. Toluene to benzyl alcohol is again a repeated question. But, well, let's see how do we do this. There are many methods. Heating with freshly precipitated manganese dioxide can do this in 1 step, yes. But a more classical method as per NCERT would be, you take chlorine and HNO. You get CH2Cl and simply add aqueous KOH. You get benzyl alcohol. This is one method. Or, let me change color to denote the difference. You could use NBS, N-bromosuccinimide, and very selectively you get benzyl bromide, and same aqueous KOH would give you again benzyl alcohol, whichever way you want. I have told you 3 ways, and there are still more, but enough, right? 5th, benzene to 4-bromo-nitrobenzene. Now you have nitro and you have bromo both. How do we do it? Please note, nitro is meta-directing group. If I add nitro before, then I would have to add meta to it. Bromo, Br group is ortho-para-directing. This is good. So I use bromine with AlBr3 and I get bromobenzene. Very good. Benzene is a big group. It is ortho-para-directing, and because of its bulk, ortho is not good, so it is typically para-directing. So what do? Then I carry out nitration. I get para, yes, this is major product. I will also get some ortho product also. I'm not saying I won't get. This is minor. Fractional distillation. Fractional distillation will easily separate them, and you have this product, and this is what you wanted, and this is what you get. Important part is, please do not carry out nitration first, because nitration is a major deactivator, and also it is meta-directing group in case you have NO2 before. So you would get meta-bromo, not para-bromo in that case. Got it? Right. Sixth question, you have benzyl alcohol. And you wish to convert this to 2-phenyl ethanoic acid. Very interesting. This OH, you wish that it changes to COOH. How do we get that? That means you are planning to add one carbon atom. See, it is not just important to get the answer, it is important to get the idea. How do you get that? Now, a very good idea of adding carbon atom with COOH group is add a cyanide group. Just imagine, if I have CH2, CN, right? And if I boil this with H plus H2O, cyanide is always hydrolyzed to COOH. Yes. Will I get this? Yes. What happens to nitrogen? Nitrogen forms NH4 plus and you can separate it. It is separated automatically. If I get the cyano derivative, it will give me my product. Now OH, instead of changing it to COOH, now my job is limited to changing OH to CN. Now OH is not a group which is very easily removed, but I could actually change this to chloride by simple PCl3. Wow, yes. I have this, and chloride has to be changed to cyanide, my dear, come on. Let's not be ashamed. Simply add potassium cyanide. SN2 attack, classic substitution, very easy and very beautiful. I would get, it's a strong nucleophile, potassium cyanide, chloride changes to cyanide. 3 steps. Add PCl3, potassium cyanide, followed by acid and boiling, and you get your desired product. This is the method. Ethanol to propanenitrile. Ethanol. This is 1, 2, 3. Propanenitrile. Well, what has happened? This OH has changed to cyanide, CN. Remove OH, add CN. Now you know this, come on. We have just done that. Add PCl3. You get, instead of OH, you get Cl. Yes. And Cl, add potassium or sodium cyanide. Classic SN2 attack. You get this plus KCl. Simple, beautiful 2 steps. And you have this, right? The next one, aniline to chlorobenzene. Now NH2 group you have intentions to remove and you want to change it to Cl. How do we do that? 2 steps. Once again, first is diazotization, NaNO2. I'm sorry. This is NaNO2 dilute HCl. The moment you have NaNO2 or sodium nitrite, what happens? You get HNO2. HNO2 reacts with NH2 group, primary amines, and it forms a very classic compound, benzene disonium chloride, BDC. Benzene disonium chloride. And now it appears that your assignment is to change this BDC to chlorobenzene. Do you remember any reaction? Yes, Sandmeyer's reaction, indeed. How do you do this? cuprous chloride. Sorry. Add KCl with CuCl and you find chloride. It's a radical mechanism reaction. You get chlorobenzene, nitrogen of course gets liberated, and you get chlorobenzene. In short, Sandmeyer's reaction. Yes, indeed. Ninth, 2-chlorobutane to 3,4-dimethylhexane. Now this is 2-chlorobutane. It has 4 carbons. 3,4-dimethylhexane. 1, 2, 3. And now we have 4, 5, 6. 4, 5, 6. Yes. And if you notice carefully, we have 1, 2, 3, 4 dimethylhexane. If you just care to see, yes. Can you see the same thing which I am seeing? We don't know, sir, what you're seeing. Well, let me show you this. If you just care to notice, well, this is your reactant, yeah. And what about the product? And this looks like the product. I just write it twice, the same molecule. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I'm just motivating you to imagine. How's it? Yeah. You place 2 molecules and you just couple them, you just add them. How can you do that? Well, Wood's reaction. So all I need to do is just add sodium in dry ether. That's it. I have shown you the trick here. The way in which it gets joined. Just simply 2 molecules combined. This is the new bond which is formed. This is the new bond which is formed. They just add Wood's reaction and you get this. That's it. 10th, you have propene. 2-methyl-1-propene. Fine. 2 propane, 2-chloro-2-methyl-propane. That doesn't sound very difficult. What they're doing essentially is they're adding HCl. What do? You just add HCl. It's Markovnikov's addition, nothing else. You add HCl, you get this simple, most branched, hydrogen atom gets attached preferably to the carbon which already has more number of hydrogens. This has 2, this has 0. H goes here, Cl goes here. It is simple Markovnikov's addition. That's all. Add HCl. Ethyl chloride to propanoic acid. We just did something very similar. From 2 carbons, you are going to 3 carbons. That means you have to add 1 carbon and it has to be COOH group. Imagine you have cyanide here. When you imagine COOH, imagine cyanide. That's a trick. And if you just add acid, you add water, you boil. You get carboxylic acid. Fine. How do I get cyanide here? Come on. Add sodium or potassium cyanide. That's it. You could use ether solvent, which is fine. Other solvents are also okay, but simple 2 steps. You add carbon using cyanide, then hydrolyze. That's it. Simple enough. 12th, but1ene to n-butyl 1, 2, 3, 4 iodide. N-butyl iodide. How do we do this? Well, as you note, this seems to be anti-Markovnikov addition. And we know very well that anti-Markovnikov addition cannot be done by HI or HCl. It is done only by HBr. So what do? We add HBr in presence of peroxide. Radical mechanism, I get H, I get Br. But I don't need Br, I need I. Okay, take it easy. Finkelstein's reaction. Add Ki in acetone. SN2 attack. I minus moves in, KBr gets precipitated out. From acetone, I get these two steps. First is peroxide effect, HBr addition, anti-Markovnikov, followed by Finkelstein's reaction. You have 2 chloropropane and you want propane 1-ol. Now this is interesting. How do you do that? Not difficult again. How do you do this? Get propene. How? Alcoholic KOH, heat. Propene to propane 1-ol, anti-Markovnikov addition of water. Hydroboration oxidation, we started with that, right? So you add B2H6 in THF or any dry ether, and then you add H2O2 with basic medium. You get anti-Markovnikov addition of HOH, and beautifully you get this. Simple, direct 2 steps. Good enough. Isopropyl alcohol to iodoform. Oh my God. How do you do this? Well, for iodoform test, you need methyl ketone. So what do? We oxidize this to acetone. How? Just use K2Cr2O7 or K2CrO4, any oxidizing agent. You oxidize isopropyl alcohol to acetone, and then iodine, base, heat. Heated with iodine and a little base, you get iodoform very beautifully along with CH3COO minus, which we throw away. We get as much iodoform as we wish. That's how. Chlorobenzene, wine, fine. And we are changing this to para-nitrophenol, OH and NO2. Fanciful. How do we do this? We can carry out nitration, yes. How? On which grounds? Where? If you have, there are 2 ways to do this. Let me tell you both the ways, then I'll ask you a good question also. Method 1. We use what is called as Dow's process. We have chlorobenzene. By Dow's process, we use NaOH, 350 degrees Celsius, high pressure, and we get phenoxide ion like this, which is okay. Now you just cool it down, add acid, you get phenol. And this you can use for nitration. Conc HNO3, Conc H2SO4. OH group is ortho-para-directing, so I get OH NO2. Of course, I also get one more OH NO2. This is steam volatile, I can remove this, this remains, so I get this. They can be removed by distillation. This is one method. Is it good? You have to tell me this. Is it good or bad? But then I'll tell you this is method 1. And what is method 2? Let's take a look. Chlorobenzene, right? Now we have nitro and phenol. Let us first try for the nitro business. Yeah. Let's do nitration first. Conc HNO3, Conc H2SO4. I would get ClNO2 and I will also get ClNO2. Which we separate by distillation. Now this Cl and NO2 is there. Because of this NO2, Cl gets activated for nucleophilic aromatic substitution, and I heat it with Conc NaOH. Not to 350 degrees Celsius, just consider NaOH. If I heat, I get a substitution. Beautiful, like this. This is the way we do it. And that's it. Maximum, at the end you acidify just to make sure that H plus is here. So 2 steps, first this and second this. Now, this is method 2. I also told you a method 1 in which we first did attached OH group, and next we did nitration. Which is the better method, first or second? Second is the better. Why? Please remember, once you have made phenol, in method 1 we made phenol and then we carried out nitration, and during nitration most of the phenol gets destroyed because it is highly reactive. So it is more useful to first nitrate it and then convert it. Yield will be better. Second is a superior method as compared to the first one. 2 bromopropane to 1 bromopropane. Come on, this is very simple. And the way it goes is, you have 2 bromopropane and you want to convert this to 1 bromopropane. This does not require a genius. Just think about this. Come on. The simplicity is, just add alcoholic KOH. So many things have similar step like this. And then carry out bromination. HBr in presence of peroxide. This looks like a repeated question nonetheless. And you get anti-Markovnikov addition and you get H and Br added like this. Radical mechanism of addition. This is how you get it. Chloroethane to butane. Life just could not get simpler. How? You get this red bond. Wurtz reaction once again. Sodium and dry ether. 2 carbons going to 4 carbons. One step straight, flat, no greatness involved. Benzene to biphenyl is again a repetition. Old questions have been shamelessly repeated in NCERT, which is a hallmark of NCERT. How do we do this? Well, AlCl3 and chlorine. You get chlorobenzene, and then you use Wurtz-Fittig reaction. How? Sodium and dry ether. Mechanism is radical mechanism and you get biphenyl like this, straightforward. All this was a part of question number 10.10. Same parts have been repeated with utter shamelessness here. Tertiary butyl bromide to isobutyl bromide. This is tertiary butyl bromide. And if we wish to convert this to isobutyl bromide, this means that Br should come here. Okay. How? The drama is very similar. First, alcoholic KOH, heat. You get isobutylene. And then, come on, tell me this. Add HBr, anti-Markovnikov addition, in presence of any peroxide like benzoyl peroxide. This is HBr addition like this, and you get isobutyl bromide. Last and the least in this section, aniline you wish to begin with, and phenyl isocyanide would be this. Carbamine test. How do you wish to do this? Add chloroform, add KOH and heat. This is all you need to do to get isocyanide like this. That's all.